Here we, here we go. Okay. So thank you. Product of roots is root of a product. Root A, root B is root AB. Root A over root B is root of A over B. Okay, so ratio roots is root of a ratio. But we can go a little better to what's called rationalizing the denominator. Root A over root B, we can root A over root B, we can multiply above and below by root B. The idea being in the bottom, you just get B, and the numerator you get root of AB. So ratio of roots is root AB divided by B. A piece of advice, a bit of typographical advice, always make the divide sign longer than the root sign. Otherwise, you might get confused, and confusion is not your friend. So long divide sign, root AB, long divide sign, B. Now, cube root of A over cube root of B, we can do the similar rationalizing the denominator trick by multiplying numerator and denominator by cube root of B squared. That way, cube root of B times cube root of B squared is cube root of B cubed, or B. And then the numerator, you get cube root of AB squared, all that divided by B, and again, make the divide sign longer than the root sign to avoid the possibility of confusion. I know it feels a little bit like saving time. It'll save you a microsecond to make that divide sign short, save you a millisecond. Oh no, it'll cause you minutes of trouble. Don't do it. Okay, so for example, root 3, root 15. Well, that's root of 3 times 15, root 45. Oh, but this has a square factor, root 9. So this is root 9, root 5, or 3 root 5. Square root of 2 over 7. That's root 2 over root 7. We'll multiply above and below by root 7. Root 2, root 7 is root 14. Root 7 is 7. So root 14 divided by 7. Cube root of 3 over cube root of 2r. We'll multiply numerator and denominator by cube root of the square of 2r. So cube root of 2r times cube root of 2r squared is cube root of 2r cubed, or just 2r. In the numerator, you get cube root of 3 times cube root of what turns out to be 4r squared. So you multiply them inside, and you get cube root of 12r squared, all that divided by 2r. That. 4 over root 6, multiply above and below by root 6. Get 4 root 6 over 6. 4 and 6 cancel, the common factor of 2. So you get 2 root 6 divided by 3. 48x squared over 8x squared y. Well, okay, first let's merge into a single square root. Square root of 48x squared over 8x squared y. 48 over 8 is just a 6. X squared over x squared cancels. We're left with a square root of 6 over y. Multiply above and below by root y. And so you get in the numerator, root 6y. All that divided by root y is y. Now here we have a square of a sum of square roots. Well, all right. We'll expand the square of a sum. Square of the sum is square plus twice product plus square. Root 3x squared plus twice root 3x root 3 plus root 3 squared. Here, root 3x is 3x. This multiplies a 2 times 3x times 3 is root 9x. And this is plus a 3. This 9 is a square, so we pull it out. 3x plus 2 root 9 root x plus 3. Root 9 is a 3. 3x plus twice 3 root x plus 3. And so here we get in the end. 3x plus 6 root x plus 3 is the conclusion. Now, if you have sums of roots in the denominator, we can rationalize the denominator by a trick, namely. Remember that a sum times a difference equals a difference of squares. And if these things here are square roots, then these square roots of squares cancel. So root a plus root b times root a minus root b equals a minus b. We'll use this to rationalize the denominator. Here's the trick. 1 over root 5 plus root 2. We'll multiply numerator and denominator by root 5 minus root 2. This root 5 plus root 2 and this root 5 minus root 2 are called conjugates. So what we'll do is rescale by the conjugate of the denominator. Now on the top is this root 5 minus root 2. Here, root 5 plus root 2 times root 5 minus root 2 is 5 minus 2. So, in the end, root 5 minus root 2 all over 3. Here we have root 7 minus root 2 over root 7 plus root 2. We'll rescale, multiply above and below, by the conjugate of the denominator, root 7 minus root 2, above and below. All right, root 7 plus root 2 times root 7 minus root 2 is 7 minus 2. Root 7 minus root 2 times root 7 minus 2 is a squared plus 2ab plus b squared. Root 7 squared plus twice root 7 root 2 plus root 2 squared. Root 7 squared is 7, 2 root 7 root 2 is root 14, 2 root 14, 2 squared, root 2 squared is 2, 7 minus 2 is 5, 7 plus 2 is 9, and so on the upshot. 9 minus twice root 14 divided by 5. Okay, this one is a rightness. 3 root 2 minus 5 root 3 over 2 root 3 minus 3 root 2. We'll take that fraction and we'll rescale by the conjugate of the denominator. Root 2 root 3 minus 3 root 2, its conjugate is 2 root 3 plus 3 root 2. Multiply above and below. All right, difference times sum is a difference of squares. 2 root 3 squared is 4 times 3. 3 root 2 squared is 9 times 2. For this, we'll use FOIL in the numerator. 3 root 2 times 2 root 3 is 6 root 6. Outer, 3 root 2 times 3 root 2 is 9 root 4. Inner, minus 5 root 3 times 2 root 3 is 10 root 9. Last, minus 5 root 3 times 3 root 2 is minus 15 root 6. Now, all right, if 6 root 6 minus 15 root 6, we'll put them together. 6 minus 15 root 6. 9 root 4 is just 9 times 2. 10 root 9 is 10 times 3. 4 times 3 minus 9 times 2 is 12 minus 18. So here, minus 11 root 6, this is minus plus 18 minus 30, which comes up to minus 12. So minus 11 root 6 minus 12 over minus 6. And cancel the minuses. 12 over 6 is 2 plus 11 root 6 over 6. There we are. Okay, more examples. Did I? I'm not being redundant again, am I? I am. 7s. Yep. Root 3 root 15, like above. Is root of 3 times 15 is root of 9 times 5 is 3 root 5. Here we have 6 root AB cubed times 8 root AB. Well, 6 times 8 is here. Merge the roots, root of AB cubed times AB here. This is 48. Root of A squared, b to the 4th. Square root of that means you take half each power. So 48 of a to the 2 halves times b to the 4 halves, so 48 ab squared. Oh dear, these are redundant. We did this before. Root 3x plus root 3l squared. First term squared plus twice the product plus the last term squared. First term squared is 3x, last term squared is 3. This comes out to 2 times 3 root x, so 3x plus 6 root x plus 3, as above. As here, root 2 times 7, that's square root of 2 times 7 over 7 times 7. That's root 14 divided by root 49 makes it 7. Root 14, all that divided by 7. Cube root of 3 over cube root of 2r. Multiply numerator and denominator by the square, by the, here be 4r, root 4r squared. So the numerator we get root 12r squared, and the denominator get 8r cubed. So in the end, cube root of 12r squared, all that divided by cube root of 8r cubed, which is just 2r. So this cube root of 12r squared, all that divided by 2r. Okay, root x minus root y over root x plus root y. We'll multiply numerator and denominator by the conjugate of the denominator, which is root x plus root y. Its conjugate is root x minus root y. This times this is the difference of squares, x minus y. This times this is the square minus twice product plus square. So in the upshot, x minus 2 root xy plus y, all that divided by x minus y. This is the same as the one I did upstairs. Let me take a look. 3, 2, 5, 3, 2, 3, 3, 2. 2, 5, 3, 2. Yeah, same thing. Okay, so multiply above and below by the conjugate of the denominator from minus a plus. This is the difference of squares. So that'll be 4 times 3 minus 9 times 2, or negative 6. Here we do a FOIL, combine terms. Minus 12 minus 9 root 6 over minus 6. And then cancel negatives. 12 6 is 2. 9 root 6 over 6 is 3 root 6 over 2. Here we have some lookalike problems. 3 root a squared, what's that? Whereas 3 plus root a squared, what's that? Okay, this is square, you distribute the square. 3 squared is 9, root squared is a, so 9a. 3 plus root a squared, well, square of the sum is square plus twice product plus square. 3 squared is 9, twice the product is 6 root a squared is a. 9 plus 6 root a plus a. Here they're being cute. Square of a root of a difference and square of a difference of, well, not even a root this time, whatever. Okay, for this one, square root of a root cancels n minus 6. Here, square of a difference is square minus twice product plus square. So root m squared is m, twice this product. It's minus 12 root m, 6 squared is 36. All right.